momentum equation. Before we start, just recall what is a momentum. Momentum, when you have a body that moving with the mass and velocity. So the products of this mass and velocity, it will create a momentum, right? The products of these two, mass times velocity, mv, you will get momentum. Okay, so momentum in this chapter, we'll use letter P for as a momentum. Yeah, so just recap what you learned in your physics. Yeah, okay. Then today we're going to put everything in one formula. Okay, so we now focus on the control volume coordinates, and we will assume that all the particles or all the movement in the control volume will be at rest or moving at a constant speed. Yeah, so this is what we will assume. So we will recall what is the Newton law given us by this equation. So I just explain with you what is momentum. Momentum is mv. Again, in this chapter, we use P as a momentum. So okay, so let me go back to second Newton law. If you mention second Newton law, you need to recall what is second Newton law. F equal to ma is second Newton law. So again, we need to expand this equation so that we can prove that actually there's a momentum inside this equation. So we break the acceleration. Acceleration is the change of your velocity. We break the acceleration. Acceleration is the velocity by time. So the products of mv divided by time, it actually is second Newton law. And we know that the product of mass times the velocity, we get momentum. So in this case, we replace P as momentum. So actually, there is a momentum equation inside second Newton law. Yeah? So we can write in this term. So force equal to momentum divided by time. So there's a rate of changing of your momentum. And the second equation that you see on the screen here is actually a mathematic model for the product of mass times velocity. So here we know that we have a constant speed as the definition in the second line here. So since we have a constant speed, v, the only changing entity is your mass. So we can only integrate the mass. So we write integration of velocity times the mass, the change of mass. All right. So and then I think something wrong with this equation because we know that if we want to calculate mass, we can take density times the volume. We get mass. So if you integrate with volume, there's a rho missing inside this equation. Yeah. So make correction for your revision material. So there is a typo error in this equation. They should, when you convert mass in term of volume, there is a rho v there. So there's a rho v, rho velocity times the dv here. So this velocity you carry forward from the previous one. Only I need to highlight this one. Yeah, there's a typo error in my slides. Okay. So let me correct these slides. You will get a rho. Okay, rho v here. Then it will be more correct information. Okay. We will move to next slide. So at this moment, when we talk about second Newton law, you should call out F equal to ma. rewrite the equation in the term of mass times velocity divided by time, you will get this equation. And then this is the integration when there's a change of mass or there's a change of volume. Okay, so these are basic equation that every time we deal with the momentum. And then when we want to analyze the problem, like what we did for the previous example for continuity equation, we always look at two basic force on the body or on the structure or on the system. So it consists of two. One is body force, one is a surface force. Yeah. So we always start, we want to find the force inside a control volume. We always start with the force equal to FB plus FS. So body force and surface force. Again, recall what is body force. Body force is always under the effect of gravity. So what gravity acting on is on mass. Gravity will pull anything that will have mass to a certain direction with G. So body force is always linked with gravitational force. And what is interested for gravity is the mass. So remember, body force is about mass and gravity. Surface force is about your control volume, that anything go in or go past your control volume. And in the control volume, you remember that we assume we have a rectangular or a cube. So a cube have 6 faces. So as long as it go in, it will come out, right? So when you integrate the vector product, so just be careful, yeah. So always recall when there's area vector and velocity vector, like what we cover in our previous chapter or previous slides. Remember, we always start with the opening always pointing out with this area vector always pointing out, and then velocity, you look at the system whether it's going in or going out. So if you have v1 vector, the dot products of v1 dot a vector, if the two arrow is parallel, then you get a positive value. If you have velocity going in, for example, you have a vector 2 like that. So the products of vector 2 dot a vector, you look at the arrow is opposite, then you get a negative products. Yeah? So on the left hand side is vector form, at the right hand side is all the scalar form, or only you have the magnitude of that one. And before I move on, just recall the concept of axis, x, y, and z. So all the direction to the x, we will use u. Or the velocity, the velocity to the x direction, we use u. If the velocity to y direction, we use v. If the velocity to z direction, we use w. Yeah. So just recall, and then you look at a certain case, and then you replace the direction. If you only focus on x, then you change the v according to the axis. So these are the basic. Okay. Now we use a general equation like what you see on the screen here, the second equation. We have n replaced as any entity that you want to calculate. So it will equal to integration of something, rho v plus something, rho v dot dA. So again, we are looking at what changes in the control volume, what changes in the control surface. And for momentum equation, we know that we will change the equation. We will replace the general equation, this one, the red color with, for example, the n here, we'll replace with P, because when we talk about second Newton law, F equal to ma again, you should now understand why I can write mv divided by t. So you have a momentum over there. So you replace the momentum as P in this chapter. So you write dP over dt, and then the rest is the n will become as a velocity. velocity vector in this case. So how you know that this is a momentum quantity? Is you just do a dimension analysis or dimensionless analysis. So you take velocity times the density times the volume. So you do the dimension or unit analysis. Velocity is meter per second. Density is kilogram over meter cube. Volume will be meter cube. Okay, so when you cancel, you will get kilogram meter per second. So again, you break this unit. You know that kilogram is mass and meter per second is velocity. So the products of mass times velocity, you get momentum. So from this equation, from the equation itself, you can tell that you are writing a momentum equation. Yeah, and the second one also same. It's only the change of your momentum. Okay. So there's a difference between continuity equation, and that's why okay. So I'll show you the third equation. So this is the momentum equation. The third one is a momentum equation. The P here is not pressure, is momentum. In this chapter, we use P to represent momentum. The rate of your momentum, the rate of change of your momentum, equal to what happened in the control volume plus what happened in the control surface. So remember the form. If the question asks you to find something and you call out the continuity equation and momentum equation, you will get the free 2 marks just for the equation. Right? So again, it's very easy to score for this module. Okay. So again, remember, this is the equation that you should memorize for today lecture. This is the momentum equation. Okay. So this is the form of momentum equation. Again, on the left-hand side, it just show you the general form. And then right-hand side will be what happened in the control volume and what happened in the control surface. Okay, this is just a mathematics model. We just say that you can find the forces in the system. So this is actually the second line of mathematics model here is just a presentation of your second Newton law, F equal to ma. Okay, F equal to ma equal to mv divided by t. So again, it's p divided by t. It's just a rewrite of the second Newton law equation. And when we have the system and the control volume met together, meaning if your control volume and your investigate system happen to be exact location, then the force will be the same for both body. One is on the system, one is on the control volume. And then this is just a derivation for what we have. So we can calculate force. You can break the equation into two halves. On the left will be you calculating the force. Again, recall what is force. Force is the body force plus surface force. Right? This component, you need free body diagram. Free body diagram. It means what it means by free body diagram, meaning you draw a body with all the forces going up, going down to the side like that. So you draw a free body diagram, something like that. And then on the right hand side here is the movement of your momentum. One is in the control volume, one in the control surface. So remember, what is the difference between these two? Volume and surface. This one you have six surface, yeah? Yeah, six surface. Six face. If you have 3D problems, if you have three-dimensional problems, you have a 2D, you only have 4 faces. Why? Because if you draw a control surface in a 2D form, you only have a square or rectangular shape, or other than other shape, but minimum you will have 4 faces. So, or 4 area to calculate. So when you have a uniform flow, so you have two equations here. On the top here is for non-accelerating cases. Then you use this equation. And you have a uniform flow for inlet and exit. You use a second one. Means you modify the second term here to add up all what happened to the control surface. Yeah? We add up all what happened to the control surface here. Okay. So we have done for all the general equation. Important for this stage that you recall what is momentum equation. F equal to mv, and no, not F equal to momentum equal to mv, right? Momentum P in this case equal to mv. And again, recall second Newton law, F equal to ma. You can write F equal to ma equal to mv divided by t. And the momentum equation, you always start with the total force that you need a free body diagram again. You draw all the force with the free body diagram. You solve for the left-hand side. Consists of body force and surface force. What related to body force again? It related with mass and gravity. Surface force will happen to what happened to the surface. Right, surface will be all the force in the free body diagram. And then the right hand side, you always remember that the first term here is del T and focus on control volume. The second term here is on the control surface. Yeah. Okay. So the third equation here is just a reminder of what is body force. Body force is mg. So how you get mg? How you get your m? You take the rho times volume times the gravity. So again, your rho and g is a constant. So the only thing that can change in the system is volume. So you take rho g, integrate of your volume, or you can write in this term. What happened in the control volume is integration of your rho g dv. And then this one actually is the mg is a weight that you learn in your physics. So to simplify or to recap or recall what you learned in your physics into this module, we will use capital W with a vector form because it's a direction going down. Then we have a subnode of control volume below there, right? Equal to mg. So there is a 3 form for body force. When you want to deal with momentum equation for your test or for your assignment or for your final exam, when you want to calculate for body force, you can body force FP. You have three form that you can use. Sometimes straight away you can use mg, but if you build a control volume, if you're forced to use control volume, but most of the time you'll use the first term here, first form here. You use this one. And sometimes this term will be given in the question. The weight of the control volume will be given, and you just substitute the value as the body force. And then we have deal with body force already. The second one is surface force. Remember, surface force is always due to the pressure. Yeah, and the force here is F. Body force here is also F. Body force is gravity. Surface force is pressure. And then recall what is the equation for pressure. So pressure equal to force divided by area. Right, pressure. So you want to find force, you just rearrange. The force, the first surface force is pressure times area. So you know that your pressure is a constant. It can be a constant. So what you can change is the area. So when you write mathematical model, you integrate the pressure with the A. Why there's a negative there? Why there's a negative there? There's a reason. So because your pressure always acting in this behavior, you always compress your surface. So when you have an extension force, we have a positive sign. When you have a compressed force, we talk about force. When you have compressed force, we use negative sign. So this is a universal notation to explain your answer after you calculate. Let's say you calculate the force, the surface force, you get a negative. It means that the pressure or the force is acting on the surface. All right, it's a negative sign like that. Okay, so remember to carry a negative sign when you build your equation. Yeah, so these slides will show you what is body force, what is surface force, how you calculate it, what are the concept behind all this, and then you apply in the specific problems or statement. Okay. So from these slides alone, I think you can guess the steps when you solve problems. The first, you start with the force. Try to think what is body force. Again, body force is deal with gravity, mg. Surface force will deal with pressure. Again, call what definition of pressure, convert into force. So this one, you need to build a free body diagram. You need to draw all the forces on the body. And then on the right hand side, you go for the momentum analysis by integration. One in the control volume, one in the control surface. Right? So there are four main idea that you should have in your mind every time you solve a problems using momentum equation. First, you think about the force on the left hand side. Then you go ahead and solve for the momentum equation on the right hand side. Yeah. So there's a different form between continuity equation which we learned previously. Today we have a different form of momentum equation. Okay, so again, this is just a recap. What mean by body force? What mean by surface force? One is due to the gravity. One is due to the pressure. Okay, then the rest you can find. So we will have our momentum equation in vector form. So this is just an explanation of what is the momentum equation will be look like if you only focus on a certain direction. So on the first here, on the top here, you can rewrite the equation. If you only focus on x direction, then you just add a notation of x below here. And then you change the u vector here as a small u because it's in the x direction. You change the u vector here as u. The rest you just copy. Same applied for y. You change the u to v. You change the control surface velocity vector into v. If you analyze on z direction, you will change to w if you are dealing with v. Just give you a tips, your coming test, you will deal with not a conventional axis. Maybe you'll be seeing z axis in the question. So just make a note in your revision or somewhere in your handbook or your notes there. Be careful when you look at a question, the axis will be given. Sometimes I will just give you y and z like that in a question rather than the typical x and y. Take note there. Look for the axis in the question. Don't assume that it always will be in this one. I will test your awareness in your during your exam. So if you solve the question by using the normal x and y, the whole question will be gone. Meaning you will sure get the wrong answer. Okay. All right. So any question for these slides on x, y, z coordinate or x, y, z momentum equation?
No, sir.
Good, yeah?
Yes.
Okay, good. Then we go for this one. We look at momentum for non-accelerating control volume. Then the next slide is just the same thing like the previous slides. The only changes is the second term here. If it's in x direction, then change to u. If it's y, change to v. If it's z, change to w. Yeah. So we have two scenarios when it comes to momentum equation. Look for the keyword in the question. If it say that non-accelerating, or you have a non-accelerating means you have a uniform flow, non-accelerating control volume, then you use the first one. Or when you see there's a uniform flow at inlet and exit, then you use the second one. Yeah. So again, if the question is uniform flow, you write the first equation, I will still give you marks, right? Because it's still a valid momentum equation. Yeah, don't worry about it. It's more on the application of the equation. Okay, before we go on, I think we have a short break when we look at the tutorial question. Okay, we come back to the tutorial after a short break. Let me stop the recording.